Alright, in this video we are going to talk about how to model expressions using algebra tiles. Normally I would do this in person and you would have algebra tiles so we could talk about what they are on the screen compared to what's in front of you, but this is not the case right now. So right now we're going to deal with virtual algebra tiles, so I will post this site on how you can access these virtual algebra tiles, but let's jump right in. So as we're going through this, you're going to be asked some questions, so make sure you're paying attention. With this, well, before we talk about how to model this, we need to talk about these. So you may recognize these as the like the blocks you use to build number places. A single one was a ones place. Usually your rectangles were tens and then the squares were hundreds, or I may be mixing those numbers up. But this is very similar. The small square is still your 1, so every time you have one of these small squares, or right now the yellow small squares, that's a positive 1. Anytime you have a rectangle, that's an x, so that's going to represent your variable. And then anytime you have a bigger square, that's going to represent x squared. Notice that these are yellow, green, and blue. They're colorful, bright. Those are your positive values. Anytime you see red, that is negative. So it's same size square as the positive one, but it's now red, so this is negative 1. Same rectangle for x, but it's now red, and it has a negative. Same thing with the negative 1. So this is now negative. And same thing with the bigger square, the x squared, but it's now red. So now that we know those basics, we need to talk about how would we model 3. You may want to pause it for a second before I go into how to do it and see if you could figure that out. You should have came up with 3 yellow 1s will give me 3, and that's correct. Let's do another one. What about 3x? Some of you may have thought, well, if I do 3 and then I do an x, that'll be 3x. But notice what happens. This is telling me that I'm adding each of these things together. And because I'm adding each of these things together, this gave me x plus 3 and not 3x. So with this, we have to think about this as 1x, like there's an invisible 1 in front of it. So if we want 3 x's, we need 3 of these rectangles. All right, let's try another one. 4x squared. Some of you may have thought that it was 4 and then x squared. But notice it did the same thing that just happened with the 3x. This is saying x squared plus 4, or 4 plus x squared. And we need 4x squared. So we need to, again, pretend or assume that there's a 1 in front of this x squared. And if we need 4x squareds, that means we need 4 of these. Right? Now, let's try some negative ones. Negative 2. If you guessed that it was 2 negative 1s, you were correct. What about negative 4x? If you guessed that it was 4 of these negative rectangles, you were correct. Let's try one more. I'm going to keep going through this until I get one that I want. You may have guessed already, I'm trying to look for a negative x squared. I have not seen one so far. Oh, there's one. So in this case, just like with the 4x squared, I'm going to take 3 of these negative x squares, and that would give me my answer. Now let's try a little bit more complex ones. Now we have 3x minus 2. Let's take this into parts. 3x, well, we know how to do that. That should be 3 positive green x's. Negative 2, or minus 2. Here, that's really the same thing. It's saying the same thing. So, because this is always adding, I can't put in positives or it will say plus 2. And we don't want that. So if we wanted to say minus 2, we need negatives. And now, even though this site is adding, because we put 2 negatives, it automatically subtracted. So this would be 3x minus 2. What about negative 3x minus 5? If you guessed that it was 3 of these negative reds, and then because of what we just did with the negative 2 or the minus 2, if you thought it was also negative 5 or 5 of these negative ones, you were correct. Now, you may get freaked out, or it may freak you out that there's so much negative or everything's positive. Can we have all of those negatives, or can we have all of them positive? Can they be both negative and positive? The answer is yes to all of that. They could all be negative, just like this example. Our last example was positive and negative. They could both be positive. It doesn't matter. You just have to follow this expression. Let's do another one. I think all of these are just x's and ones or negative ones. So let's try a harder one. Well, now we have 3 terms. We have an x squared term, we have an x term, and we have a constant, where we have 2 variable terms and a constant. Doesn't really matter how you put this together. If you want to start with that constant because you know that's 2 yellows or 2 positive ones, you could start there. If you know that this positive 3x would be 3 green rectangles or 3 of these x's, you could go ahead and put that up there. So this part looks the same, 3x plus 2, and now we just have to get this negative 2x squared. Well, if we think back to how we did that before, we had to get the bigger x squared, or the bigger square, and however many of them they needed to give us negative 2x squared. So even though we started at the end and worked to the front, we still got the same answer. And that's because in this case, this site is taking what you have and putting it in the correct format for you. Normally what you would want to do if you were doing this by hand or on paper is start with the first term and work your way back, and not what we just did. But in this case, on this site, it doesn't really matter. Take a second and try to do this one. Pause the video if you haven't already. And what you should have gotten was 1x squared minus 3x plus 1. Anytime you think that yours is similar but something's not right, always read this. So let's say I put a negative instead. Oh, hold on. Because they already said this was correct, I'd have to do something else. So notice that this won't tell you that it's correct until you get it correct. If you have to keep adding things in or trashing things, you can do that until you get that correct. And it will eventually say correct. If you really want a challenge and you're on this site, go to random. That way this will go through all the easy, medium, and hard, and you can do that at your own pace. This will really help you in the second part of today's lesson.